So you already learned about the stack, and this stack is the concept of last in, first out. There's one problem that we can apply stack. So in this problem, it is the problem about computing spans. So it is not in the book, but I think it is good to learn about this computing span. So for this computing span, we want to use the stack as the auxiliary data structure. We want to use stack as auxiliary data structure in algorithm. So let's see how this algorithm works. Given an array X, usually we call array, or in Python you can use list, and we want to see the span. The span Si of Xi is the maximum number of consecutive element Xj immediately preceding Xi such that Xj is less than or equal to Xi. So the easy way to understand this one is using this table and with this visualization. We can apply this to the financial analysis, for example, the stock price. Let's say X is the stock price. I have the stock price is 6, and this is the period 0, period 1, 2, 3, 4. Maybe this is month, or we can say this is week, week 1, week 2, week 3, and so on. Now the price on the first period is 6. The price in the second period, it becomes 3. And the price in the third period, it becomes 4. The price in the fourth period, it becomes 5. The price in the fifth period, it becomes 2. So I want to know when I should buy or when I should sell by looking at the trend. So the trend will be something like this. If I know that the number is maximum, okay, then I will just monitor this one. If it decreases, then I will start from the beginning and I look the trend again. If it goes down again, then it will start again back to the position number 1. So if you can see here, the S or the span, it will be 1 at this period because it is the first. And when it is down, the position or the span is still 1. But when the price is rising, okay, we can see the price is rising, then we want to know the position. Okay, now it is the position 2. Now it is 3. But when it goes down again, so we will return back to 1. Okay. It means I know that if it is going down, then maybe it is time for me to sell, or we need to have a caution about this stock price. So how can we create the algorithm? How can I make the S? So we need to check every time the number by looking at this condition, whether the Xj is less than or equal to Xi. If this one is less than this one, then the S start from 1. If this one is higher than this one, then we will add the span. So the first algorithm, I can say it is the quadratic algorithm. The quadratic algorithm means the processing, it will take quadratic. Or we have the big O and power of 2. Let's see. I have the algorithm span x comma n. The input is this one and the output is this one. Okay, so when you design your algorithm for your team project, please remember you need to know what is the input and what is the output. So let's say this the input is array x, and then the output will be the span. So S will be the array of n integers, and I would like to look from 0 until n minus 1. So if I do the first operation, I know that it will run for n times because there will be n integers. For this for loop, I know that this will run n times because it is the for loop from 0 until n minus 1. For this operation, it is 1. Okay, one operation because this is just an assignment. Because it is inside the for loop, then it will run n times. We have while. This while s less than I, so s is started by 1. So s is the variable to indicate the span. It will start from 1. So while s less than 1, so we have this symbol. This symbol is to represent n. Okay, you know the n operator in Python. You can apply the n operator, but for this pseudocode, we can just say with this symbol. And the xi minus s less than equal to xi. So we want to know the span. The span means this one. So if I have the span equals to 3, so the minimum will be the I minus this one. I minus the span. So if the xi minus s is less than equal to xi, and if the s is less than I, so we will increase the s. If you look at this while, we need to check what is the possible operation time. We have this s less than I. It means if I equals to n minus 1, then it means I have the possibility when s equals to 1, then there will be the worst case scenario from 1 until n minus 1. It means this while loop, the worst case scenario will run at least n times. So if we have the n times for the for loop, and then if we have the n time for this while loop, then it means there will be n multiplied by n time. N multiplied by n, it means n power of 2. So this is the worst case scenario. But of course you can say, yeah, there will be only 3 cases. Yes, that's possible. There will be only 1 cases. Yes, it's possible. But the worst case analysis, let's say if the price is rising. Then when it is 1 until it is n minus 1, it will be looping every time. After we finish with this loop, so we just assign S into the span or SI. So we will get the S. So the span 1, it runs on power 2. Usually, when we have the algorithm with n power of 2, there is a possibility to improve it. There is a way or there is an alternative to improve so that we can have maybe n or maybe log n. How? If we can apply the basic data structure, for example, stack. It is not always possible, but there is an alternative. For this computing spans, there is an alternative using stack. Because if we look at the price, like this number, actually we can just look at the final price or the maximum price. So we can use stack. We keep in a stack the indices of the element visible when looking back. So when we look back, we just look at the last one. So we can scan the array from left to right. So we can scan from left to right. And then let I be the current index. We pop index from the stack until we find j such that xi is less than equal to xj. Then we will set the si, which is I minus j, and then we push x onto the stack. We know that the stack operation is only 1. Then if it is 1, and if we have n possible numbers, so the maximum will be n times. So we can have a new algorithm, not the quadratic, but we have the linear algorithm. Each index of the array is pushed into the stack exactly 1 and is popped from the stack at most 1. So here we do not need to use the previous while for every numbers. So we will just consider with the stack. So as it will be the array, the algorithm is the same. It has 2 parameters, x and n, and then we have a new stack. So in this case, the stack you can apply list, or you can apply any data structure in Python. And then the same thing, I would like to do the loop from 0 until n minus 1. So I would like to check if the stack is empty or not. So as long as the stack is not empty and the top is less than or equal xi, and more. We know that the stack is just one operation, and then this also one operation. So even though we have while, then it will just run for n times. Because we have only the stack to indicate what is the element in the stack. So if the stack is empty, so we will add by 1. Otherwise, I will use the SI as the I minus the A dot top. And then at the final stage, I will put what is the value into the stack. So with this stack, it will be always one operation, and this one operation will run for n times. So it will be n times. So the statements in the while loop are executed at most n times. So the algorithm span2 runs in on time. Okay, this is the stack. You learn about the abstract data types and the example and how we can optimize the algorithm with stack. So let's take a look on the code. I give you the IPYNV. So I took this code from the book. This is from the author Goodrich. Whenever we use the basic or the abstract data structure, they will use class. So this is the array stack. We have the init, this is the constructor, and we want to put the data, and we want to check the length. Okay, we can also check whether the stack is empty or not. We have push, it means we are going to append the element. Okay. I think you know when we use list, okay, we can add the element by append. And we can check the top of the element. The top of the element means if it is not empty, then the top of the element will be the data -1. But if it is empty, so you can just give the exception is empty. When you do the pop, it means you want to remove. So you will check whether the stack is empty or not. If it is not empty, then you can just do pop. So pop is the method in the list. So if you do pop, then you will remove the last element. So let's say if I have this one. So you already learned from the class. The S is an array stack. So the first I would like to push. So it means there will be an element 5. I would like to push 3. So I would like the new content will be 5,3. And then if I want to know the length will be 2. If I want to pop, then I will remove the last element, which is 3. If I want to check whether the S is empty or not, the output will be false because I still have one element. I would like to pop, then it will show the result 5 because I remove the top element. And then I want to check whether S is empty or not. Yes, it is true because now it is empty. If I push 7, then the new content will be added with 7. If I push 9, it will be added by 9. If I want to know the top is 9 or the end of the list. I push 4, then the list will be added by 4. If I want to check the length, then it will be 3. If I want to pop, then it will return 4, and 4 will be removed from the list. If I want to push 6, then 6 will be added. I want to add 8, so I can just push 8. And then if I have to pop, then it will be 3. And this will be the final list. Yep, so this is the step by step. So if you run this, then you will get the result only in the print section. Okay. So the other example is about parenthesis matching. Okay, this is the parenthesis matching. So we want to know whether the text contain the pair of this parenthesis or not. Okay, we have the lefty and we have the righty. So the left should have the element of this parenthesis. The right should have the element of this parenthesis. In this case, we can apply the array stack. Okay. And then, yeah, you know, last time we learned about this. So you can try is match. Now I will give a kind of problem. So parenthesis, 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 this is the opening. And then parenthesis, 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 this is the closing. So I can check, okay, this is true based on this is match function. So for every C in the expression, what is expression? So this is the input. This is the input. So I would like to check for every element this one. This one, is it in the lefty? Okay, if it is in the lefty, then push into the stack. And I will check for every of this element. If it is not in the lefty, then I will check whether the element is in the righty, or this may be the closing. So if it is in the closing, so you know already about in. Then if it is in the righty, then I will check whether the S is empty or not. So if the stack is empty, of course it is false. Because the closing should have the opening. So if the stack is empty while we find anything in the right, of course it is false. And then we need to check whether the righty index C is not equal to the lefty index S the top. It means I want to know if the parenthesis is the same to check with this one. The number of the index, okay, it will be important. If it is not the same for the index, then it is false. So the index means this one 0, 1, 2, 0, 1, 2. Okay. So we will also match the index. Return is empty. If it is empty, then it is true, because there will be no element in the stack. Because here you will pop when everything is already matched. Now I can have another example. This one, opening, 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 and the closing is only 2. So it is false. There is another algorithm to check the HTML. So I also give you the HTML. It means we want to check if the tag, we call it HTML tag. I want to check whether it is matched or not. So we use the array stack, and then we want to find the triangle bracket. So if we find this triangle bracket, then while j is not equal to -1, it means if we can find the element, we will enter this two. So if we cannot find, then the element will be -1. If we can find, then the element will be any number higher than 0. Or it can be 0, because when we want to find one kind of element, it starts from the index 0. So we want to find the k, and then if k is equal to -1, then it will be false. So it means if we cannot find any of this closing, then it is false. So we will do with the look, this one, we want to check the tag. So the tag, it will be the element from j plus 1 until k. And then if the tag is starting with this one, it means if we have the element in HTML, the closing should follow with this symbol. So if the element is not starting with this one, then we will push this one into the stack. If it starts with this one, then we will check whether the first element it is in the stack or not. So if it is not in the stack, of course it is false. And if there is no element in the tag, then it is also false. So thus we will just return the s as the stack. If it is empty, then it is true. If it is not empty, then it is false. So for example, usually in the HTML, we need to use the HTML, and then we need to end with /HTML. So if we have this HTML and then triangle bracket /HTML, then it is correct. If we have this one, then it is not correct, because the name of the tag should be the same. But this case, HTML, and in this case, body. So it is not the same. That's why the result is false. And then this case, I have body with triangle bracket, and then I have body with the slash to indicate the ending. And then I have HTML, and I have the HTML with the ending. So if I want to check whether it is matched with the HTML, yes, it is true. So we already learned the span, computing span. Okay, the one that we just learned for the computing span here. And if you look at the code, the span one, it is starting with a list, and then I would like to check from all the elements. So S will be started with 1, and then I will check for every of the possible element here. So you already know about this meaning. So if it is correct, then S will be added by 1, and then S will be appended into the stack. So if I use the span one, and I use the example, this one, 63452. 63, okay, yeah, it's 2. I think it's the same. Okay, if you change to 3, I think it's the same. The result will be 1, 1, 2, 3, 1. Okay, because from the price 6, it goes down to 3, so it will start the span to 1 again. So we can also apply the stack. How if we use the stack? So I give you this code. Okay. So the S is a list, and then I will use A as an array stack. This is the same for loop, but now I am using the while, and while is using the stack. Okay. So this follows the pseudocode that you saw in the PowerPoint. Using this one, let's see if I have the same problem. So the result will show you the same. So okay, let's see this one. So 3. Yeah, the result is the same with this span. And you know this span in the worst case it will run for n times. For this span, because we are using the stack, so in the maximum it will run with the same with the for loop. Okay. Okay, that's about the stack. Any questions? Okay, I will move to the next slide. This is about queue. Stack and queue, actually they are a kind of term. When we are dealing with the stack, we will also need to understand queue. Because QADT, queue abstract data type. When we deal with the queue, QADT stores arbitrary objects. Arbitrary objects means it can be numbers, it can be string, it can be integer or float, and there will be the operation for insertion and deletion. This follow the first in, first out scheme. If you use stack, it will use the last in, first out. If you use queue, it is first in, first out. Okay. We call it LIFO, last in, first out, or we call it FIFO, first in, first out. Insertions are at the rear of the queue. Okay. So whenever you insert, it will be the rear. It is the end or the back side of the queue. And removals are at the front of the queue. So when you remove, it will be started from the index 0 or the front. The main queue operation, there will be two operations, NQ and DQ. So for the NQ, you will have one parameter. It means I would like to insert an element at the end of the queue. And if I want to DQ, there will be no parameter. I will just remove the object. So it will remove and return the element at the front. So for example, here I have the NQ. The first element is 1, and then I want to NQ2. Then NQ will be at the top. I would like to NQ3, so 3 will be at the top. I would like to NQ4, then 4 it will be at the top. I want to NQ5, okay, 5 in the top, and then I want to NQ6, so 6 will be on the top. Now, if I want to DQ, I want to remove. The removal will be starting from the first one. So 1, 2, 3, 4, 5. So this is the sequence of the removal. If you use stack, you want to remove from the top. Okay, 6, and then 5, and then 4, and then 3, and then 2, and then 1. if you use stack. If you use queue, yeah, just the common queue like you do in the activities, in the daily activities. There can be another kind of queue operation. I would like to know what is the first object. The first object means it will return the element at the front without removing it. I would like to know the length. The length means how many elements are there in the queue. And I want to check whether the queue is empty or not. So whether the list has element or not. There will be exceptions. It means the exception attempting the execution of DQ. DQ is this one. So if I want to do the DQ, but there is no element. So attempting the execution of DQ or front on an empty queue. So we will have the empty queue exception. So let's say we have the queue. The queue is an empty list. Q.nq5. So I will have the element 5. Q nq3. Yeah, the return value will be nothing. And now Q will be 5,3. If I want to check the length of the Q, it is 2. And then I have the Q as 5,3. What if I want to DQ? It means I want to remove. And the removal will be from the first one, not the last one. 5 will be removed and the remaining item is 3. Q is empty, false, because we still have one element. Q.eq. We want to remove the element, the first element, which is 3. So now it becomes empty. Q is empty. Yes. Then it is true. Q dq. So if I want to remove the element, it means it will be error, because I don't have any element here. Q.nq. So I put 7. Nothing happened in this one. Q.nq9. I would like to add 9. And then I want to know what is the first element. Okay, in this case, I have 7 as the first element. I would like to nq4, so the 4 will be added into the list. I want to check what is the length of the Q, so I will get 3, because there will be, here we have 3 elements. And dq, so I will remove the first element, which is 7, and the remaining will be 9,4. Yeah, this is the application. I think you know when you go to restaurant or you go to bank, you always have the waiting list. So that's the queue or the bureaucracy. Or if you want to use the, if you use computer, if you want to print, if there are many documents, then there will be a kind of queue. Multiple programming. So there are some if you do with the machine learning later or the computational, there will be a kind of parallel computing. So in the parallel computing, even though we call parallel, there is still a kind of queue. So which computer will do first, which computer will do next. So some indirect application, you can use queue for the auxiliary data structures. And also there are some other component for the data structure that you can use queue. When we use array, so the array, it can be in the circular fashion. use an array of size n in a circular fashion. So it means we have the array with n size, okay, and there will be two variables to keep the track for front and end. So f will be the front element and r will be the immediately past the rear element. So this will be the last and r will be the next after the element. Array location r is kept empty. So the pink color is the element that exists in the array. We call it, this is the normal configuration because you can look at the normal way. The white color is empty. But we can also do the wrap around configuration. It means some element here not empty, some element here not empty, this element are empty. So we call this is the front and this is the R. So we can look at this kind of Q operation by using the modulo operation. You know, modulo. Modulo is using the percent sign. 5 modulo 2. We call the remainder analogy. So 5 modulo 2, it means it is 1. So we can use this remainder operation to calculate the size. So the formula will be this one, n minus f plus r. So for example, I have this Q. So we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. So there are 17. Now, I want to know how many items that are available in the list. I know that this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, okay, I know there are 10 elements here. But how if I want to know with the automatically with the formula? So I can just do with this one. I know the n, which is 17. And I have to know where is the front. The front index now it is 4. So 0, 1, 2, 3, 4. Okay, this is the front index. And what is the R? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And using this formula, we have 17 minus the front, which is 4, plus R, which is 14. And then we will do the mod or the modulo n. N is 17. Then we can see 27 mod 17. 27 mod 17 equals to 10. So we know that we have 10 elements in this cube. What about this one? I know the F. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. The F is 11. And then what is R? R is 0, 1, 2, 3, 4. Okay. Using this formula, then we have 17 minus F, it is 11, plus R, which is 4. Okay. So 17 minus 11, 6 plus 4 is 10. Okay, 10 modulus 17. So modulus 17, it is 10. So I can know that the size now we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 elements. Okay. So this is the algorithm to find the size. The algorithm will be empty if the f equals to 1. Okay, so there's still. Okay, I will continue. Let's have a break first.